Okay, here's another question involving a rough inclined plane. And in this case, we've got a box of mass 10 kilograms, which slides down a rough inclined plane as shown in below. The angle between the plane and the horizontal is 60 degrees, and the coefficient of friction between the plane and the box is 0.4. So, find the resultant force acting on the box. Well, same old pattern that we're used to now. We put in our weight, which is 10g. We put in our reaction force perpendicular to the plane, R, which we'll find out in a moment what this is, R. And because it's a rough plane, we've got friction, and because the box slides down the plane, the frictional force is going to be in the opposite direction, which is up, and it's going to be equal to mu r, where mu is the coefficient of friction, 0.4. Okay, so first things first, resolve the weight into its two components. The component pointing down the slope, which is sine, and the component into the slope, which is cos of the weight force. So we're going to have 10g cos of 60 degrees and 10g sine 60 degrees. That's resolving this weight into its two components. Right, so dealing with the forces perpendicular to the plane first of all, and taking the upward direction as positive, we're going to have, using our notation, R minus 10g cos 60 is going to be equal to 0, because the block does not move above or below the plane, it always stays on the plane. Now you can see that we can solve this and immediately find that R equals 10g cosine 60 degrees, and if I get my calculator out and turn it on, check that it's in degrees, and we have 10 times 9.81 times cosine 60, which is a half, isn't it? And we get 49.05 newtons. So I'm going to call that 49.1 newtons. So we found our reaction force. Right. Now we need that because when we come to the next part, we're going to deal with the forces down the slope. We're going to need a value for R to put in to find out our frictional force. Right, so let's treat the forces down the slope, so I'm going to take downwards as positive, and that means that 10g sine theta, sine 60 I should say, I keep saying theta, but theta is just the angle of the slope, so it's 10g sine 60 minus mu r. Now this is not going to be 0 because there is a motion down the plane, and you'll notice they didn't say anything about moving at constant velocity down the plane, so therefore we could assume that it will be accelerating down the plane. And in fact, what I think is a good idea, because we're now going to indicate use a symbol for acceleration, it's a good idea to indicate that it's going to accelerate down the plane by putting an A, and once again, always use a double arrow for acceleration because that is a different type of vector to these force vectors. So this is going to be the resultant force down the plane is going to be the mass of the box times the acceleration. Now I've just noticed that part A is just to find the resultant force acting on the box. So the resultant force acting on the box is actually going to be this number that I'm going to work out. And it's only after that I'm going to need to worry about the acceleration for part B. So for part A, this is part A. All I need to do is to plug in the values of G, mu and R into this equation. So I get 10G sine 60 minus u is 0.4, so it's 0.4 times 49.1, and that is going to be my resultant force. And you can see that if I plug these numbers into the calculator, I'm going to get 10 times 9.81 times sine 60 minus 0.4 times 49.1, and that turns out to be 65.3 newtons. So 65.3 newtons, and this is the resultant. This is the force down the plane. Okay, this is the force down the plane, and we know that the resultant force of these two forces cancel each other out, so they're zero. So this is the resultant force. So let's just let the examiner know that this is the resultant force that we're after for part A. Okay, now let's look at part B now. Now for part B, we have to calculate the velocity of the box after 2 seconds, assuming it starts from rest. So first we need to calculate the acceleration. Which is, so as we've said already, the resultant force 65.3 newtons. The resultant force is going to equal the mass 10 kilograms times the acceleration A, and therefore the acceleration is going to be 6.53 meters per second squared. Okay, now we need the acceleration because we're now going to use the Suvat equation, which will allow us to calculate the velocity given the acceleration and the time. Now remember, the Suvat equations that we want are we've got v squared equals u squared plus 2as, we've got v equals u plus at, and I think you'll realise that it's going to be v equals u plus at. So if I'm using the v equals u plus at equation, we know that u is the initial velocity, and we're told that that is 0 in the question. It starts from rest, so therefore we know that u equals 0. So this is going to become v equals 0 plus the acceleration 6.53 times the time, we're told is 2 seconds. So the velocity after 2 seconds is going to be 13. Let me just check that. It's going to be 2 times 6.53, 13.06 or 13.1 meters per second to 3 significant figures. Okay, so that's the another example of an inclined plane question.